Welcome to homework.
We are going to find right here the hybridization about the central atom. So basically, which orbitals are we going to use um, to help those molecules to hybridize? So first thing that we're going to do is that we are going to draw the Lewis dot structure for this to find how many domains, and according to the domains, how many orbitals are being used. So we know that selenium has 6 valence electrons and chlorine has 7 valence electrons, but since we have two atoms, they're 14. So in here, I am looking at a total of 20 electrons. So now what I'm going to do is that I'm going to draw the structure of this. Okay, so I'm trying to do as symmetrical as possible. And these electrons right here are telling me that I need 20 electrons around this all atoms. Remember that you always begin putting electrons in the outer atoms, and then if you have leftovers, you're going to complete to the center. So I already have 2 and 2, so there's 4, meaning that I need 60 more. So 4, 6, 8, and 10, 12, 14, 16, 18, and 20. Now I'm going to check that each one of them have 8 electrons around. I always said let's check if they are happy because remember that they are extremely happy if they have 8 electrons around. So if you count the electrons around this chlorine, you see that it has 8, this chlorine has 8, and this selenium has 8. So now everybody's happy. Now I'm going to count how many electron domains this selenium has around. So this selenium has 1, 2, 3, and 4. So there are 4 electron domains. So if selenium has 4 electron domains, it means that it will have 4 orbitals. I'm going to represent those orbitals with lines 1, 2, 3, and 4. And then I'm going to label those lines. Remember that we have orbitals S, P, D, and F. So S can only have or only have one orbital. Then the next one in energy is P, and P has 3. So these 3 are going to be labeled P, meaning that the hybridization in here or the orbitals that that atom is using to make hybrid orbitals are 1s, 1, 2, and 3p's. Now, let's follow the same procedure for the H3O plus molecule. H has 1 valence electron, but I have 3 atoms, so that's 3. Oxygen has 6. And in this case, I have a positive charge in here, meaning that this whole molecule is losing 1 electron. So I'm going to subtract 1. And I have 8 electrons in total. Now I'm going to put my oxygen in the center. I'm going to put 3 hydrogens. And now I need to put 8 electrons around. I already have 6. Remember that hydrogen cannot have more than 2, so I'm not going to touch these outer atoms. And my leftovers is going to the center, that is O. And now everybody's happy. Remember, oxygen is happy with 2 electrons, and not oxygen, hydrogen is happy with 2 electrons, and oxygen is happy with 8. So now let's count. Again, I have 4 electron domains. If I have 4 electron domains, that means that I have 4 orbitals. I'm going to translate my 4 orbitals to lines. So I have 4 lines. The first orbital is named S, and the next 3 are labeled P. So again, oxygen is using 1 S and 3 P's orbitals to make hybrid orbitals. And the last one is IF4 negative. So now let's count. I has 7 valence electrons. Fluorine has 7, but I have 4 of them, so that's 28. This is an ion and an ion, so that means that I'm gaining 1. So in total, I am looking at 36 electrons. And we're going to do exactly the same. We're going to draw first the structure, and I'm going to say that this has an F in here, an F in here, an F in here, and F in here, because I always try to draw it as symmetrical as I can. And now I need to put 36 electrons around. Always begin with the outer atoms. You already have 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, and 36. If you see, everybody's happy. You can also see that iodine can make extended octets because iodine has d orbitals that it can share. So it is okay that that iodine has more than 4 electrons. So now let's count. In this case, iodine has 1, 2, 3, 4, 5, and 6 domains. So it has 6 electron domains, mean that it has 6 orbitals. And now I need to draw 6 lines. 1, 2, 3, 4, 5, and 6. The name of the first orbital is S. You know that after S you have P, and P has 3 orbitals, so these 3 are P's. And then the next in energy is D's. So these 2 are the orbitals. So that means that iodine has 1 s orbital, 3 p orbitals, so 3, and 2 d orbitals to make hybrid orbitals.